Hi everyone. In this video, we are going to discuss about block diagram prediction rules. Concept of block diagram prediction. So why block diagram prediction rules requires? So why block diagram prediction rules requires mean? So for example, any control system, any control system is given in terms of block diagram. For example, any control system is given in terms of block diagram representation. So because of that, we can use block diagram prediction rules. So what is the block diagram? Block diagram is a graphical representation or pictorial representation of each and every component in control engineering or control system. The definition of the block diagram is a graphical representation or pictorial representation of each and every component in control engineering or control system. Because of their simplicity, block diagrams are often used by control engineers. A block diagram can be used to simplify and to represent the composition and interconnection of a system. The block diagram can be reduced to find the overall transfer function of the system. The block diagram can be reduced to determine to find the overall transfer function of the system. So what is the transfer function of the system? The transfer function of the system is given by or defined as ratio of output to the input to the system. Output of the system to input to the system. So now here the following rules can be used for the block diagram prediction rules. There are some important rules we can reduce the block diagram prediction rules. So that are, first one is and the first rule is combining the blocks in cascade. So combining the blocks in cascade. So in the given block diagram, if the blocks are connected in the series form or cascade form, that all the series blocks are combined into a single block. So multiplication, now here suppose for example here there are two blocks and this is the block 1 and this is the two blocks, second block, and these two blocks are in series form or cascade form. So combining the blocks in cascade or series, multiplying these two blocks, so we get the resultant block is, this is the equivalent representation of this cascade connection. So now here in this cascade connection, the input to the block is capital A. Capital A is an input to the block, and this input is passing through the block, and output of the first block is A into G1, A into G1, and the second block input is A into G1. This A G1 is passing through the second block, and the output of the second block is A into A G1, G2. And this cascade connection is represented in terms of G1 into G2, that is, these two blocks can be represented in terms of single block. This is the equivalent representation. Here also the input is A, this input A is passing through this block, and the output of this block is A into G1, G2. In this diagram and in this diagram, the output is same. So now here, so reducing the cascade connection, simplifying the blocks. In the given block diagram, two blocks or more than two blocks are connected in a series form or cascade form. That series blocks are represented into a single block. So that is the multiplication of G1, G2, G3 and so on like that. So that is the rule 1, combining the blocks in cascade. And the second rule, combining the blocks in parallel. Combining the blocks in parallel. So now here there are two blocks G1 and G2. These two blocks are parallel to each other, and this is a summing point. This is the summing point. So these two blocks are combined into equivalent representation is G1 plus G2. G1 plus G2. And this is the summing point. And this summing point here the input is capital A, and this is the branch point or the takeoff point. And there are two blocks here, G1 and G2. These two blocks are parallel to each other. And this block input is also A, and input is passing through this block, and output is A into G1. And output of this block is A into G2. And output of the summer or summing point is A G1 plus A G2. A G1 plus A G2. So now here both the terms is common. Therefore A into G1 plus G2. A into G1 plus G2. And these two parallel blocks are combined into a single block. That equivalent representation is this one. So now here in this block the input is A, and this input is A is passing through this block, and the output of this block is A into G1 plus G2. Both the blocks outputs are same. So in the given block diagram, two blocks or more than two blocks are in parallel form, that all parallel blocks are combined into a single block. So that is, now here G1 and G2 are these two blocks are parallel. So combining these two blocks, we get the equivalent representation is this one. So that is second rule. And third rule is moving a summing point after the block or ahead of the block. Moving a summing point ahead of the block or after the block. And this is the summing point. So moving summing point or branch point away from the block or before the block, away from the block, after the block or before the block, we can consider another additional block. Now here the rule is moving a summing point behind the block, moving a summing point after the block. So moving this summing point after the block, now here consider another additional block. Now here we can choose another additional block. Here we can represent another additional block. So therefore equivalent diagram is moving the summing point after the block. After the block means from here to here. Moving this branch point here to here, and equivalent representation. So moving this branch point after the block, here consider another additional block. That additional block is G. So this is the equivalent representation of this block, moving the branch point after the block. So now here the summing point input is capital A, summing point input is capital A, and another input is this is B, and the output of the summing point is this is a plus and this is a minus, negative feedback, and the output of the summing point is a minus b, and this a minus b is passing through this block, and output of the block is a minus b into g, a minus b into g. Now here in this block the equivalent representation, the input signal is capital A. This input is passing through the block and output of the block is A into G, A into G, and this input is A, and this block input is A, and output of this block is A into G, and the summing point one input is AG and another input is AG. Now here the negative sign is there, and the output of the summing point is AG minus AG. For both the terms A is common, therefore A into A, sorry, this input is not A, B. Now here what is this input? This one B. And this input is B. This B is passing through this block, and the output of this block is BG, and output of the summing point AC minus BC. Now here the G is the common, A minus B into, that is equal A minus B into G. So moving this summing point after the block and the equivalent graphical representation, consider another block G, another block G. Next rule, moving the summing point ahead of the block, before the block, moving the summing point before the block. So moving the summing point, moving this summing point before the block, here consider another additional block, and the equivalent representation is this. Moving this summing point before the block, here consider one additional block, that equivalent representation is this one. Here in this block, the input is capital A. This A is passing through the block, and the output of the block is AC, and this summing point, another input is capital B, and the output of the summing point is, now here the negative sign is there, and the output of the summing point is AC minus B. And moving this branch point, moving this summing point before the block, okay, here consider one additional block, so that is this one, that additional block is 1 by G, and this summing point input is capital A, and this block input is, what is another input? B, and this input is B. This B signal is passing through this block, and the output of the block is B by G. And what are the summing points of the input? One input is A and another input is B by G. Now here the negative sign is there. The output of the summing point is A minus B by G. So moving this signal into this block, we get the output of this block is G into A minus B by G. Multiplying G in the bracket term, we get AG minus, in the second term, numerator and denominator G is cancelled, we get only B. Therefore, and the output of the block is AG minus B. And next, another rule is moving a branch point or takeoff point after the block. Moving the branch point, this is the branch point, and this is the branch point. Moving this branch point after the block. So moving this branch point after the block, consider another additional block here. Consider one additional block here. Therefore, the equivalent representation is this one. Moving this branch point after the block, here we consider another additional block. That additional block is 1 by G. So this is the equivalent representation moving the branch point after the block. So now here the input is capital A, capital A, and this input is also capital A, capital A, and the output of this block is AG, and moving this branch point after the block, this is the equivalent graphical representation. Here the input of this block is capital A. This signal is passing through this block, and the output of this block is AG. And what is the input of this block? This input of this block is AG. So this AG is passing through this block, and the output of this block is 1 by G into AG. Numerator and denominator, G is the cancel, we get only A. And this output is also AG. So moving the branch point or the takeoff point after the block, the equivalent representation is this one. And next rule, moving the branch point or the takeoff point before the block, and this is the branch point, and this is the branch point or the takeoff point, moving this branch point before the block. So moving this branch point before the block, we can consider another additional block here. Consider one more additional block here. Therefore, the equivalent representation is this one. And the input of this block is capital A. This A is passing through the block, and the output of the block is AG. Output of the block is A into G, and this output is also AG, and this is also AG. And here this input is A, and this is the branch point or the takeoff point. So moving this branch point or the takeoff point before the block. So here the input is A, and this block input is A, and the output of this block is AG. And this signal A is passing through this block, and the output of this block is AC. And this output and this output both are the same. So moving the branch point before the block, and this is the equivalent representation. Here consider the another additional block, that is this one. So we keep in mind, so moving the branch point before the block or after the block, or moving the summing the point before the block or after the block. So consider one more additional block. Next rule is interchanging the summing point. Now here there are two summing points. This is one summing point and this is another summing point. Interchanging the summing point. So this summing point inputs are A and B, and output of this first summing point is A plus B, and second summing point inputs are, and output of the first summing point, that is the one input, and another input is C, and output of the second summing point is A plus B minus C. Now here the negative sign is there. So interchanging these summing points, interchanging these two summing points. So interchanging these two summing points, so the equivalent diagram, interchanging these two summing points, and this is the equivalent diagram. Replace this summing point in this position and moving the summing point in this position. That is the interchanging of the summing point. And what are the inputs? One input is A and another input is C, and the output of this summing point is A minus C. Now the negative sign is there, and this is the second summing point. One input is A minus C and another output is B, and the output of the second summing point is A plus B minus C. Next, splitting the summing point. So this is the summing point, splitting this summing point. Splitting this summing point into two summing points. So one is, this is the one summing point and this is another summing point. So in this summing point, inputs are A, B, C and output of this summing point is A plus B minus C. Now the negative sign is there, that is minus C. Splitting the summing point, so this is the equivalent representation. The next rule is combining the summing point. So combining these two summing points. These two summing points can be represented into a single summing point. So that is equivalent representation, this one. Next rule is elimination of the negative feedback. Elimination of a negative feedback. This is the summing point and this is the forward gain, that is the open loop gain, and this is the feedback bar, feedback bar. Now where the negative feedback is there. How to eliminate the negative feedback? And the input of this summing point is R. This R is passing through and this is the feedback loop and the output C. And what is the input to the feedback loop? R minus C H into G. So this is passing through this block. We get the output is C into H. Sorry. And the input to the feedback element is C. So this is passing through the feedback. The output of the feedback is CH. And the output of the summing point is R minus CH. So eliminating this feedback, we get the equivalent block is G by 1 plus GH. G by 1 plus GH. Where G is the open loop gain and H is the feedback power. Feedback power. And C is the output and R is the input. Therefore, the transfer function C of S by R of S is equal G by 1 plus GH. So this is the elimination of the feedback. And another rule is elimination of the positive feedback loop. And the previous rule is elimination of the negative feedback and the negative sign. Now we have the positive feedback. So eliminating the positive feedback. So this is the positive feedback closed loop control system. So eliminating this positive feedback, we get the equivalent representation is G by 1 minus GH. So therefore, the transfer function is C of S by R of S is equal G by 1 minus GH. So these are the block diagram reduction rules. So using these rules, we can reduce the complicated blocks. Thank you.